Wow, hello guys, welcome to my channel. Welcome to Master Builders Online Academy, the very online academy where you can learn all the tips as to how you can gain mastery to any calculation course at all. Don't forget, this is a continuation class, and then I want to take out this time to appreciate every one of you who are subscribers to this channel. Thank you for coming around. Thank you for leaving your positive comments at the comment section. We are seeing your comments, and we are seeing how you are liking our videos, sharing our video, then recommending this channel. We love you guys. Now in this module, I'll be teaching you again a basic aspect of complex number, and in this video I'll be teaching you exactly how to perform an operation in complex number. What is this operation? Multiplication and division of complex numbers. So, all right, guys, now we are welcome. I hope you actually that prayer. If you have not, please go back and make sure you pray that prayer so that whatever I teach here will gladly enter your mental capacity and build it once and for all. Okay, now let's get into the business. So we are still dealing with the operations of complex number, and then we are looking at multiplication and division of complex numbers. Like we said before, there is possibility of either multiplying two or more complex numbers, and in the same way, there is also a possibility of dividing one complex number by another, multiple complex numbers by another. All right, so it's as simple as this. So, but the question is, how do we multiply one complex number by another? Now, get this clear. In order to multiply one complex number by another, we simply use the theorem of expansion of brackets. And then, if you are not good with that, you can actually check the description of this video so you can get a link to our videos that cover everything about expansion of bracket. But otherwise, you can check the playlist and just look for mathematical expressions, and then you are able to navigate yourself through and get all that you need. But I hope that at the end of this video, you are able to learn everything that you need to know to gain mastery in this aspect of this. The division of complex number, we actually apply the rationalization law of sort. Are you there? One of the basic things is that the division, this rationalization aspect comes in because in every complex number you are dealing with, it is highly prohibited that you leave your answer having an imaginary symbol at the denominator. Just the same way that when you are dealing with surds, all right, you don't leave your answer having a square root at the denominator. It is the presence of the square root at the denominator that brings about the rationalization of sort. The same thing here. Anytime you have the iota symbol, which is the imaginary symbol at the denominator, you rationalize to be able to eliminate that imaginary part from that denominator. That is all about the essence. So without wasting much of our time, let's dive into solving problems under these basic operations. Alright, so guys, as you can see, we have question number 4 on the board, and as you know, this is a continuation class. So if you are getting to watch this content on complex number, please guys, you can check the playlist and then look out for complex number so you can get access to previous content that was made on this topic before this very content. But if you have covered those areas and then you are still having some lapses, please don't forget to replay some of these videos over and over again until you are able to gain the full knowledge that is required. Alright, so now we have question number 4, and then we have given that Z1 is equal to this, Z2 is equal to this, Z3 is equal to this. The same complex numbers that were given while we were dealing with addition and subtraction of complex number as that aspect of operation is the same thing that we are given here, but only that we are to perform different activity, different tasks with the same complex number. In the first question, in that part of addition and subtraction, we were adding these numbers and then subtracting them from each other, right? But in this case now, there is a basic or another task that is required from us. As you can see, having given us the same complex number, the first question is find Z1, Z2. So when I have A, B, for instance, mathematically, it is the same thing as A multiplied by B. So if I have Z1, Z2, it is same thing as Z times Z2, which mathematically you can also use bracket Z1 multiplied by Z2. Alright, so this is it. These are basic notations. So now the first operation or the first thing that we are asked to do now is to find Z1 multiplied by Z2. Okay, now we have solution. Number 1, Z1, Z2. And then what is our Z1? We have 3 plus 5i. Then multiply minus 7 plus 3i. Now, there is something you need to understand anytime you are dealing with multiple products of imaginary sign, or when you are dealing with multiplication of complex number. You really need to understand that I raised to the power of this is -1. We've done this before now, so we are going to be applying this because anytime you multiply two complex numbers, you are bound to have I squared. And anyway you have I squared, just substitute in -1 there, and then you are good to go. Alright? So what we need to do now is that we are multiplying this bracket by this bracket. So this is why I said you are actually using the law of expansion. Now let me bring you to this place. Assuming I have A multiplied by P, then into X multiplied by Y. Let's say this is what I have, exactly what we have now. Let me use this to illustrate how this product or how this task will be performed. Now in this case, you actually multiply this term by this, and then multiply this term by this. Then again, you multiply the second term by this, and then multiply the second term by this. What it means is that you take the first term in the first bracket and use it to multiply the two terms in the second bracket. And that's how we get these first two directions at the topmost part of this expression, right? So take A, which is the first number here, to multiply the two numbers in the second bracket. When you are done with that, put down the result. Then take the next number in this first bracket to also multiply the two numbers in the last bracket. So if this condition is obtained, then you are good to go. So this is actually A multiplied by X plus A multiplied by Y, then plus B multiplied by X, and then plus B multiplied by Y. That is exactly what we are going to do. So if you understand this, you really have issues. But like I said earlier, if you really want to understand the concept of algebraic expansion very well, just check the playlist of our channel, and then you'll be able to see algebraic expression where you can learn everything you need to know about algebra. Are you there? Okay. Now, all we need to do now in this case, so we are going to be multiplying 3 by -7, and then this will give us -21. Then this 3 will also multiply 3i, and then this will give us 9i. I hope you understand what I'm doing here. We are done using 3 to multiply the two terms here. Then again, we move to what? 5i, which is the second term, which is standing in terms of b now. 5i multiplied by 7i would have given us -35i, and then 5 multiplied by 3 will give us 15, and then remember, I multiplied by I will give us I squared. And understand that I squared is equal to -1. Don't forget this. Then as we move further, this will give us -21. Remember that the middle terms will always be a terms in I imaginary to the power of 1. So this is 9i, and then this is 35i. Hope you understand this. So 9 minus 35 would have given us -26. I hope you get what I just did there. So when you remove 9 from 35, you have 26. And then plus 15 multiplied. Remember that I raised to the power of 2 is -1. Now, I'm doing this for this first question. For every other questions we're going to solve, all you need to do to eliminate or to remove I squared, change this sign to opposite sign. So now that we have 15 here, if I want to remove this I squared, I will turn this to -15. That's all. But for this case, now let's just substitute this way so that you understand the basic concept. By the time we start invoking this concept, to no longer be a problem again, right? So at this point, this will give us -21 minus 26i. 15 multiplied by -1 will give us -15. So it's simply changing the sign to its opposite sign. Then at this point, lastly, as you can see, we have two real numbers, -21 and -15. They are the real numbers. So minus 21 minus 15 would have actually given us minus 20 minus 37. I have minus 37 minus 26i. This is the answer to this first question that we are asked to perform. Remember, even while we get to this level, we are still applying addition and subtraction law. So for every multiplication problem you have, you always bring it down to a level where you need to do addition and subtraction. Is this clear? Now let's look at question number 2 for more emphasis sake. Now question number 2, we have z1, then z3. This is equal to z1 is 3 plus 5i, and then z is 4 minus 3i. The same thing we are going to do. This first number we multiply the 2 terms here, and then this last number we multiply the 2 terms here. So 3 multiplied by 4 will give us 12, and then 3 again multiplied by negative 3, and we have minus 9i. I hope you understand this. We are not using 3 to multiply the 2 terms here. Now we move to 5. 5 multiplied by 4 give us 20i, and 5 multiplied by negative this will give us minus 15. I multiplied by I would have given us I squared. Are you there? Now we understand that this is 12. Now again, like I mentioned before, the 2 middle terms here will always be like. The 2 middle terms here will always be numbers of the same family. Okay? Alright, so the 2 middle terms here will always belong to the same category. Are you there? And then this is 9i, and then this is 20i. So that means that we can actually add them together or subtract them. So minus 9 plus 20i will actually give us plus 11i, which you can actually check out with the help of your calculator. So this is plus 11i. Then remember that I squared is minus 1. So if I introduce minus 1 here, this automatically turns to positive 15. Other than introducing minus 1 like we did before, you don't need to stress yourself or waste your time that much. So this is automatically plus 15. So as I remove I squared, I change the sign of the coefficient of I squared to its opposite sign. I hope that is clear. And then at this level, what do I need to do? All I need to do is that I have 2 real numbers. Then I can add them up together. So 12 plus 15 will actually give us 27. Then we have 27 plus 11i. It's as simple as this. Just as simple as this. Alright, now the next thing we want to do is to obtain the Roman figure 3, which is the product of Z2 and Z3. So we move to this level. Roman figure 3, Z2, Z3. Now, our Z2 is minus 7 plus 3i, and then this is 4 minus 3i. Already we know this, right? So these are the values that we have for Z1, Z2, and Z3. All we need to do the same thing we did before. The first term here, we multiply the 2 terms here. So we have minus 7 multiplied by 4 will give us negative 28. Minus 7 multiplied by minus 3 will give us plus 21i. That's for that. We are done using minus 7 to multiply the 2 terms here. We now move to 3i. So 3i multiplied by this will give us plus 12i. And then 3i multiplied by this will give us minus 9. I squared. Remember 3 times 3 is 9, and then I times I is I squared. So as simple as this. Then we have this as minus 28. Like I said, the 2 middle terms will always belong to the same categories, right? So these and these belong to the same category. This is 12, 21i, and then this is 12i. So 21 plus 12 would have given us 33i. So this is plus 33i. And like I said, anytime you want to remove I squared, just turn the sign of the coefficient to the opposite sign. So we have minus 9 here before. So in order for me to remove I raised to the power of 2, I will turn that minus 9 to plus 9. But you can actually substitute it. But what I'm trying to do is to just keep one step. Alright? Then this will automatically giving us plus 9. I hope you understand what I've done so far. Then all we need to do at this level, we have 2 real numbers, and then which is minus 28 and plus 9. So minus 28 plus 9 will give us negative 19. This would have given us minus 19 plus 33i. This is it. So we have been able to get the result for this. Then the last but not the least under the multiplication is Roman figure 4. Then we have IV, which is Z1, Z2, and then Z3. So our Z1 is, like we have here now, is 3 plus 5i. Then Z2 is minus 7 plus 3i. Then the last is 4 minus 3i. So you can see it there. Now, I wouldn't want us to waste much of our time here. Let me show you what you do. Assuming these questions come all together in one, there is something you can do here. Look at it. So I can decide to go with Z1 and Z2 first. Alright? Z1 and Z2. Now, look at it. What I mean now is that, let's come here. So now let me explain something here. Z1, Z2, Z3 is the same thing as Z1, Z2 multiplied by Z3. Of course, I already know the result for Z1 and Z2. So I can just put the result there and get the outcome. Are you there? Or I can say, okay, this is something as Z1 into Z2, Z3. And I know Z2, Z3. So whatever I have here, I will just multiply it by Z1 and I'm good to go, without wasting much of our time. But as we have it here now, I'm going to go through the long approach of this. So what we are going to do now is that we're going to work with the first two brackets. So the first two brackets is this into minus 7 plus 3i into 4 minus 3i. So you see what I'm trying to explain? Everything inside this bracket has been calculated for. Where? That was question number 1. Look at it here. Z1, Z2. So what I have inside this closed bracket is this. So I don't need to stress myself going through Israelite journey. All I just need to do, everything here, replace it with this result. I hope you understand, because even when you try to solve this out, you will still get nothing more than minus 37 minus 26i. Is that clear? So we have this as everything in this bracket will be replaced by minus 37 minus 26i into 4 minus this i. This is it. It's as simple as this. So we have solved everything here. All we need to do now is to go ahead with our normal multiplication. Minus this multiply this multiply this, we get the result. Minus this multiply this multiply this, we get the result. So when we multiply, alright, so at this level, all we need to do, 37 multiplied by 4, we get the result. 37 multiplied by 3, we get the result. Now let's multiply this out. We have minus 37 multiplied by this, we have 8. This multiplied by this is 12 plus 2 would have given us 148. Then this multiplied by this would have given us plus. Remember, minus minus is plus. And then 7 multiplied by this is 20. 111i. This is what we have. Then we are done using this to multiply this. The next thing we want to do is 26 multiplied by this. 26 multiplied by 4 would have given us minus this multiplied by this is 24. Then this multiplied by this is 8 plus 2 you carry, that would have given us 10. 104i. And then this multiplied by this would have given us plus. Remember that minus multiplied by minus is plus. And then 26 multiplied by 3, we have 18. 6, and then we have 78 I squared. This is what we have. This is what we have. Alright? This multiplied by this, we have this. This multiplied by this, we have positive 111i. Then this multiplied by this, we have 104. And then this multiplied by this, we have 78. Simple as that. All we just need to do now is to what? Add up the middle terms. So we have 148, that's minus 148. 111 minus 104. 11 minus 4 would have given us 7. So that would have given us 7 plus 7i. And then remember that I squared is minus 1. So if I am removing this, I will turn this to minus. And then this will give us minus 78. Alright, so if we remove 78, now remember this is now two real numbers as we have it here. Minus 148 minus 78 will have given us a value, so we can add them up. 148, 78, then this is 6, then this is 226, right? So this is 226. So this will have given us minus 226 minus plus 7i. This is the answer to this very question. So guys, as you can see, we have been able to provide answers to the product aspect of this question. So the next step we are going to dive into now is the division aspect. So if you are yet to subscribe to this channel, make sure you subscribe to this channel. This is the only way you can motivate us to keep uploading mind-blowing content like this. We love you guys. Let's dive into division of complex number proper. Alright, so now on the board we have next question, which is Roman figure 5. And we're told that this is Z1 over Z2. And then the Z1, we have it as 3 plus 5i all over. The denominator is 4 minus 3i. You can put bracket, you can decide not to put a bracket. It's not a problem at all. Now let's look at this. So in order to solve this division very well, please pay attention to this. You apply what we call the method of rationalization in sort. Now you understand that in sort, when you are rationalizing, you actually get the conjugate of the denominator. And what's the conjugate of the denominator? Remember we talked about the conjugate of a complex number, and as such you have a complex number here. And I did mention earlier that in complex number analysis, it is highly prohibited that you leave your answer having this I, which is the imaginary sign, at the denominator. So the only way to eliminate this imaginary sign from the denominator, just like square roots in sort, is to rationalize. And anytime you are rationalizing, you simply change the sign that connects the imaginary part to the real part, and then multiply both the numerator and the denominator by the conjugate of the complex number. So in this case now, the conjugate of 4 minus 3i is 4 plus 3i. You understand this? If this is clear, so we have this as 3 plus 5i multiplied by the conjugate of the denominator, which is 4 plus 3i. All over what we have at the denominator before now, 3i. Again, multiplied by the conjugate of the denominator. This is it. Remember that this divided by this will give us 1, which gives us this back. But the reason why we are doing this is to eliminate I from the denominator, which is the iota. Are you there? Then, if we do this, remember, what we are going to be doing here now is extraction, which is multiplication of complex number, and that's exactly what we just finished dealing with. So if you do not understand how question Roman figure 1 to 4 was solved, you can actually get it here properly now. And you then you can get it clear. So from this point, all we just need to do, like we have it here now, is we multiply this. 3 multiplied by 4 will give us 12. You all know this, right? Then 3 multiplied by this will give us 9i. Are you there? Then 5 multiplied by this will give us 20i. And then 5 multiplied by this will give us plus 15i squared. All over. And the denominator is the same thing. 4 multiplied by 4, we have 16. 4 multiplied by 3i, we have plus 12i. Minus 3 multiplied by 4, we have minus 12i. And then minus 3i multiplied by plus 3i will give us minus 9i squared. Of course, you understand that I squared is equal to minus 1. Anywhere I have I squared, I will just put in minus 1. And then I don't have that time to substitute. So what I just need to do now is I will remove I squared here. As I'm removing I squared here, I will change this sign that connects the coefficient of I squared to each opposite sign. So now that I have I squared here, this plus 15. But if I remove I squared from there, it will turn to negative 15 or minus 15. I hope you understand the law. Okay, so if that is clear, then this will have given us 12 plus 29i. Remember, 9i plus 20i will give us 29i. Automatically, this will have given us minus 15 all over. I hope you understand what I'm doing here right away, right? Then, if I move down to this other the denominator, this would have given us 16. Remember, the essence of rationalization is to have that the two middle terms must cancel out. So, minus 12 plus 12 is already 0. Now, remember that I want to remove this I square. So, this will automatically become plus 9. While I have I square here, this is negative 9. Now that I'm removing I square, it will become positive 9. This is just a simple law. So at this point, I can now remove 15 from 12 because they are the real numbers at the numerator. So 12 minus 15 will give us minus 3 plus 29i all over. When I add these two results together, it gives me 25. This is it. So you can leave your answer here, or you can as well have this as 1 over 25 into minus 3 plus 29i, or you can have this as minus 3 over 25 plus I, 29 over 25. Whichever case you want to leave your answer, you are good to go. It's either you leave it here, or you take out this in this fractional form, or you can share the denominator for both terms at the numerator. So the first numerator takes 25, the other one takes 25. This is all about this. It's as simple as this. This is all about the motion of complex numbers. I hope you understand this. Now let's look at the next question, which is VI. Alright, and in this case we have Z2 all over Z3. So now guys, what is Z2? Like we have it, Z2. Alright, so as you can see now, I actually use Z3 here. So let's take this guy as Z3. I just find out that I use Z3 here, so not Z2. Make sure you get that correctly. So let's come back here and then change this to what Z3. So it's Z1 over Z3, because while I was substituting here, I actually used the value for Z3, not for Z2. I hope this is corrected already. Now, let's do. So all over Z3 again is 4 minus 3i. This is what we have. Remember, any of them can be at the denominator. It doesn't really matter. All that matters is ability to get the conjugate of what you have at the denominator. Then multiply the numerator and the denominator by that conjugate of the complex number at the denominator. So if this is clear enough, so we have Z2 over Z3 is equal to minus 7 plus 3i multiplied by what is the conjugate of the denominator. Without wasting much of our time, it's still the same thing as we had before because we have equal denominators. So the conjugate of this is just changing this sign here to positive sign. Again, what we have here is 4 minus 3i. Multiply the numerator and the denominator by the conjugate. Alright, so having done this, the next is to expand the bracket. And now, in order to expand this bracket, what do? We simply have to multiply negative 7 by 4, and then this will have given us minus 28. Negative 7 by this will have given us minus 21i. 3 multiplied by this will give us plus 12i, and then 3 multiplied by this will give us plus 9i squared. All over. The denominator, 4 multiplied by 4 we have 16. 4 multiplied by 3 plus 12i. And then 3 multiplied by 4 we have minus 12i. And then 3 multiplied by 3 we have minus 9i squared. Don't forget that I squared is equal to minus 1. So all we need to do is to substitute minus 1 there. But meanwhile, the middle terms and the denominator will always cancel out. This is the essence of rationalization. Alright? So we have this as minus 28. At the numerator, this term and these two middle terms belong to the same category, and such we can add or subtract them from each other. Okay? So minus 21 plus 21 plus 12 would have actually given us minus 9. So this is minus 9i, then minus 9. All but remember, this is plus 9 while we have I squared. Now that we are removing I squared, we introduce a negative sign. Then we have 16. Again, we have negative 9 square here. While we have I square here, this was negative. Now that we are removing the I square, it will now turn to positive 9. Then we have this as plus 9. Okay? And then if we simplify this further, we'll have this as minus 28 minus 9 would have given us minus 37. And then we have this as minus 37 minus 9i all over 25. Like I said, you can leave your answer this way. You can as well have it as minus 1 over 25 into 37 plus 9i, because minus is common, or you can have it as minus 37 over 25 minus I 9 over 25. This is the answer. Anywhere you decide to stop, that is the answer. But if you are dealing with objective, at least your options should give you the boundary where you leave your answer. So we have been able to solve 2 questions so far on that division of complex number. Like I said earlier, they are all the same thing. Now, all we just need to do now is to look at the last 2 options that we have here, and then we are good to go. Alright, so we have Roman figure 7 here, and then we are asked to find Z1, Z2 over Z3. Of course, from this particular video, we have actually find the result, the product of Z1 and Z2. But take for instance, you are given a question whereby you have never had an opportunity to solve for Z1 and Z2. You will have to work it out here. But for me and for us together here, we have actually gotten the result for Z1 multiplied by Z2. And then we have minus 37 and minus 26. Minus 37 and minus 26. And you remember, this is what we have. Then Z3 is 4 minus 3i. So this is what we have. Remember, assuming you have never solved for Z1, Z2, you will work it out here. But I don't have that time to waste. We can actually do it here, but because we don't want this video to be too lengthy, then we want to apply the shortcut. I hope you understand what we are trying to do. But you already know the value for Z1, you know the value for Z2, you can multiply out, but the end product of Z1 and Z2 is this. And that was Roman figure 1 that we calculated from this question. So the answer we have here is just what we put at the numerator here. Now we have an imaginary sign at the denominator. All we just need to do is to rationalize. Are you there? And then in order to rationalize, this is now equivalent to minus 37 minus 26i multiplied by the conjugate of the denominator, which is 4 plus 3i, all over 4 minus 3i multiplied by the conjugate of the denominator, complex number. Okay? So this is what we have. As simple as this. The same thing we are going to do, we multiply out, just multiplication. And then when we multiply out, this will give us minus 148, that's minus 37 multiplied by 4. And then minus this multiplied by this will have given us minus 111i. And then 26 multiplied by 4. Remember, 26 multiplied by 4. We had it, all of this product we had them before now. Alright, we're supposed to put the result. We already did the product of this and this earlier before, but just a little difference between them, right? So this is minus. And then when we multiply 26 by 4, we have minus 104i. And then 26 multiplied by this, we are having this as 78. Minus 78i squared. So this is what we have all over. Of course, the denominator is not new. This is 16 plus 12i minus 12i, then plus minus 9i. I hope you understand this. This is what we have. So at the numerator, this is minus 148. Minus minus would have given us plus in summation. So 111 minus 104 would have given us minus 215i minus. Now remember, if you want to remove I squared, you introduce plus 78 all over 16. Remember that the 2 middle terms must cancel out. And then if I remove I squared from minus 9, it becomes plus 9. Then I have plus 9. At the numerator, as you can see now, we have 2 real parts. So we have 148 minus 78. 0. Put one from here. So when we remove this, we have 70. Okay, so this will have given us minus 70 minus 215 all over 25. Now, as you can see, all of these numbers here are divisible by 5. 5 can go into 25, 5 can go into 17, 5 can go into 215. It's as simple as that. So how do we get this? Our final result is 70 divided by 5. What I've given us minus 14. Then 215 divided by 5. 20 divided by 5 would have given us 4. And this is 21 carry 1. Divided by 5, that's 3. And all over 25 divided by 5, you have this is the answer. Otherwise, you can have this as minus 14 over 5 minus I into 43 over 5. This is the answer that we have. Understand that we obtain 14 by dividing 17 by 5 because 5 is a common term. And then 215 divided by 5. So we have 43. Then 25 divided by 5, we have this. This is the answer to this. So now the last but not the least is Z2 multiplied by Z3. Z2 multiplied by Z3. So we have Z2, Z3 all over Z1. So this is VII, alright? And then this is equal to. Of course, from the previous calculation, we have also obtained the result for this, which if you check clearly, is our question number 3 here. So just go to question number 3 and get the result for multiplying Z3 by Z2 or Z2 by Z. We have that Z2 multiplied by Z3 as minus 19 plus 33i all over Z1 is given as 3 plus 5i. 3 plus 5i. This is what we have. So in this case, because we have imaginary part at the denominator, we need to find a way to remove this imaginary sign from the denominator. How do we achieve this? We simply achieve this by rationalizing this expression. And then, what's the conjugate of the denominator? This will, if this is 3 plus 5i, the conjugate will be 3 minus 5i. So we simply multiply the numerator, minus 19 plus 33i, multiplied by 3 minus 5i, all over 3 plus 5i, 3 minus 5i. Remember that these last brackets are the conjugate of this original denominator. All we need to do is to do a regular expansion. Regular expansion. So the regular expansion is such that we will multiply 19 by 3. So 3 times 9 is 27. Carry 2, 3 multiplied by this is 3, that's minus 57. We have gotten the result for that. Then take 19 multiplied by 5 will give us 95, and that's positive 95i. We are done with that. Then 33 multiplied by 3 will have given us 99. We have 99i. Then 33 multiplied by 5, so we have 165i squared all over. So we have been able to obtain the product of this. So, and then if we make progress, we have 3 multiplied by 3, which will give us 9. 3 multiplied by negative this, we have minus 15i. This multiplied by this, we have plus 15i. And then this multiplied by this, we have negative 25i squared. Remember that I squared is equal to minus 1. Then anywhere I have I squared, I can introduce negative 1, right? And then if we progress, this is minus 57. This plus this, we have 95 plus 99, and then this will give us 4, and then this will give us 19. So we have plus 194i plus 165. Remember that now that when I have I squared here, the coefficient was negative. As I remove I squared, the coefficient turns to positive. I hope that is clear. In the same way, anytime you rationalize the two middle terms at the denominator, we always cancel out each other. Alright? Then we are left with 9. And the same thing that happened here is going to happen here as well. I have I squared here, and then the coefficient is minus 15. If I remove I squared, the coefficient turns to plus 15, plus 25, right? So we have plus 25. It's as simple as that. So all we just need to do now is to remove 57 from 160. We have 108. So this will give us 108 plus 194i all over. If we add 9 to this, we have 34. Okay, so as we can see now, all of these numbers here, they are all even numbers. So I don't actually know the highest number that can go in, but I am sure that 2 can divide all of these numbers. So 2 into 108, that would have given us 54. And then 2 into 9, this will give us 97i. All over 2 into this will have given us 17. So this is the final answer. Or you can have this as 54 over 17 plus I 97 over 17. This is the answer to this very question. So guys, thank you for staying to this point. If you actually watch this video from the starting point to this very point, please, it is very clear that you have gained massive value from this content. So all you need to do now is to make sure give us a thumbs up, like this video, share this video, and make a positive comment about this video. Don't forget to leave this video without leaving a comment. We love you guys. Don't forget that this is a continuation class, and this class is a series. You can check the description of this video where you will have access to the next lesson. If you are not yet a subscriber to this channel, please consider subscribing to this channel and do well to turn on the post notification bell so that whenever we upload my great content, you will be notified. And the only way you can motivate us to keep uploading content like this is to make sure you like our videos, share our videos, and then make sure you subscribe to our channel. We love you guys. See you guys in the next video where we will be looking at other operations of complex number. Thank you very much.